So this video is about how to read the HR diagram, which you see on the screen right in front of you here. This is the one that you're using for the lab for this week. It's important to bear in mind that it's just a graph. It has two axes, well actually three axes, and we'll talk about each one individually, but the horizontal axis is the temperature axis in kelvins. The vertical axis is luminosity axis in solar luminosities, and then the diagonal axis is the one that's a little bit different than the HR diagram that you see in the textbook. The diagonal axes are in solar radii, or solar. Each one is a solar fraction of a solar radius. So for example, along this line here, the 1 solar radius line, any data point, any plotting of a star that falls along this line has a radius about that of the sun, is about the same size as the sun. 0.1 solar radius, any data point that falls in that line that star will have a radius of about 1/10 of the size of the sun. Going up the scale, the stars up here will have a radius that's about 10 times the radius of the sun, or diameter, you can think about it that way. 100 times the solar diameter, 1,000 times the diameter of the sun. The HR diagram is a logarithmic scale. What that means is every time you move up a line, the spacing between the line as you move up the scale, the spacing between the lines is actually 10 times the previous distance between the spacing. So it's easy to see in these numbers here where we go from 1,000 to 10,000. So if you take a look at the spacing between the lines, it gets smaller and smaller and smaller as we approach the 10,000 kelvins line. So the marked line is 1,000 Kelvin. The next line is 2,000, 3,000, 4, 5, 6, 7, 8, 9, 10,000. Now as we move to the next line up, after that, this line is 20,000, 30,000, 40,000, 50,000, 60,000. So the scale, the temperature scale spans from a low temperature of 1,000 kelvins up to a temperature of 60,000 kelvins. But it's important to keep that logarithmic idea in mind when you're interpreting this graph and trying to figure out where you plot your original data points, because you have quite a few data points to plot on this graph. Along the luminosity scale, that logarithmic nature continues. So here's this line here is 1 solar luminosities, and the distance from 1 solar luminosity to 10 solar luminosities is exactly the same as the distance from 10 solar luminosities to 100, and from 100 to 1,000. So the scale gets compressed the higher and higher up you go on the luminosity scale. So if we interpret these, let's see, I'll try to find one where there isn't this label in the way. Well, we can work with the 1. So here's 1 solar luminosity. Next line up is 2, 3, 4, 5, 6, 7, 8, 9, 10. Gets very tight towards the top. But then the next line after 10 solar luminosities is 20 solar luminosities, then 30, and I'll go over here so we can keep going, 40, 50, 60, 70, 80, 90, 100. Now at 100 solar luminosities, the next line up is 200. At 1,000 solar luminosities, the next line up is 2,000. At 10,000 solar luminosities, the next line up is 20,000, 30,000, 40,000, 50,000, and so on up the scale. Moving down the scale is the same way. It's easier to think about it in terms of moving up the scale than down the scale. It gets a little confusing when you try to move down the scale. But if we go up the scale, same deal. Here's 0.1 solar luminosities, 1/10 of a solar luminosity. Here's 0.2. I'll move over a little to get away from that label there. 0.3, 0.4, 0.5, and then we go 0.6, 7, 0.8, 0.9, and then we get to 1 solar luminosities. 0.01, 0.02, 0.03, 0.001, 0.002, 0.003, all the way down here. It's the same way of interpreting it, all the way to the very bottom where we're at, let's see, 1, 2, 3, 4, 5 zeros and then a 1. This is 1/1,000,000th of a solar luminosity. Well, this is 2/1,000,000ths of a solar luminosity, and this is 3/1,000,000ths of a solar luminosity, all the way up to 9/1,000,000ths of a solar luminosity, and the next line up is 10/1,000,000ths of a solar luminosity, or 1/100,000th of a solar luminosity. So you can see how the counting is consistent throughout. You just have to be very careful about how you interpret what the numerical meaning of the individual lines are. The purpose for this, the reason that we have use this logarithmic scale on the HR diagram, is because the luminosity, the spread of luminosities of different stars that we see in the cosmos, and the spread of temperatures that we see amongst different stars in the cosmos is so great that we'd never be able to fit it all on a single graph if we just had a linear scale. So if we just had a scale that went from 1,000 to 60,000 kelvins with an even spacing between each temperature level, the graph would have to be as big as your kitchen wall to fit all the data on there. So to get it and down to a reasonable size, we use this logarithmic scale.